Hi, welcome to In 5 Minutes. This is the next type of problem in which they have told that if the transistor is driven to saturation, that means you know the region of operation for the transistor. Which are the different region of operation for the transistor? Forward active, you can say, then forward active, then saturation and cutoff. These are the basic three regions where we operate our transistor. So in this case, what they have told, if the transistor is biased in saturation, calculate the values of the current at that condition. So initially what we need to find the value of IB. So what we do, we apply KVL in the base emitter loop. So you need to identify the base emitter loop. This is your base emitter loop. So when you apply KVL in the base emitter loop, what will be the equation for the KVL? We are living with positive sign. This sign given in the question is always the sign with what we leave, right? So it is 8 volts. Again positive negative, we are living with negative sign, so minus IB into 220k. Positive negative, we are living with negative sign, so minus VBE equals to 0. So from this you can find the value of IB as 8 minus 0.7 divided by 220 kilo ohms. That will give you IB as 33.18 microampere. Right? We got the value of IB. The another method for finding IB is total voltage will come in the numerator in the loop upon the total resistances. So total voltages are VBB 8, VBE 0.7 divided by total resistance 220k. This is the shortcut method to find the value of IB. Right? But exams you need to write the KVL to base emitter loop, then substitute the values and then find the value of IB. Once you know the value of IB, you can find the value of IC as beta into IB. How much you will get? You will get it as 3.318 milliampere. Now we need to find the value of VCE when you apply KVL in the collector emitter loop. That is, we are starting from this point, we are going till the other point. This is your KVL loop. So KVL to collector emitter loop. What will be the equation? We are living with positive sign, so plus 10. Positive negative, we are living with negative sign, so minus current in the resistance RC is IC into RC minus VCE, because we are living with the negative sign, equals to 0. So you can write VCE as 10 minus IC into RC. That will give you how much? 10 minus 3.318 into 4. So this value will get it as minus 3.272 volts. So when you look at the characteristics of the diode, of the transistor, say it is nothing but in the output side also you have a diode, right? So when you look at the characteristics, this type of characteristics we have seen for the output. So VCE, when it is coming around 0.2, the transistor is driven into saturation and we are not going beyond 0 volts, but still here VCE you are getting it as minus 3.2, which is not possible. That is, our initial assumption of the transistor being operated in the forward active mode is incorrect. So we need to find the value of IC in the saturation region. So IC in the saturation region will be, again the same equation I am using, the same equation, VCC minus VCE sat, which is given in the question. VCE sat, if it is driven into saturation, use VCE as 0.2 volts divided by RC. So this will give you the value of IC as 2.45 milliamperes. So in the previous case, this IC what we had got was, because we were assuming the transistor to be operated in the forward active region, which is wrong. We have got the operation of the transistor in saturation region. So our new IC value is 2.45. Now whether the value of IB will change because of this? No, because we want junction JBE to be forward biased. So your IB should not change with the change in IC in the saturation region, because for the saturation region JB and JBC both are forward bias. So if we change the value of IB, your transistor might go in the cutoff region. So we need not change the value of IB as the transistor goes into saturation. Now since we have got the value of IC, we can find the value of beta. Now you have IC upon IB. IB ka value we have already found out. This ratio will give you 73.84. This is nothing but beta. Beta given in the question was 100. So because the transistor is driven into saturation, your beta is decreasing. You are having the current gain as only 73.84. right? You know the value of IB and IC, you can find the value of IE. How much is the value of IE? You will get it as 2.483 milliampere. Just substituting the values, you will get the value of IE. Now power dissipated in the transistor, it is nothing but the base current into base voltage plus collector current into collector voltage. Now VCE, we will take saturation region, IC in saturation region, whereas VB on whatever we have found, we'll keep the value as it is. So 33.18 into 10 raised to minus 6 into 0.7 plus 2.45 into 10 raised to minus 3 into 0.2. This will give you the value as 0.513 milliwatts. This is how we are finding the power dissipation in the transistor.